Welcome everyone. My name is Paul McAlister. I'm a practicing architect. I've been in practice 13 years. About 7 years ago we took a very conscious decision to look at sustainable ways of doing architecture. And one of the things that I quickly realised that one of the best programs, one of the best ways of doing sustainable and low energy housing was the passive house system. Passive house is a German system, was thought up by a German professor. And if you know anything about German cars, BMWs, they're very reliable and they're very rigorous. And the passive house system is a very rigorous and very reliable way of producing energy efficient houses or buildings. I and the practice are, so we're in the unique position that we've actually completed a number of projects which are truly sustainable. On the board there, the house on the left-hand side, that's Northern Ireland's second certified passive house. The building on the right is an educational building in Enniskillen. It has won a number of awards because of its sustainable credentials. It's passive house certified, it's BREEAM excellent, and it's carbon neutral. So in that sense, we're talking about buildings that have been built and that tick all of the boxes. So we're going to talk first about passive houses, and what I'm going to do is I'm going to end the talk a bit early and you'll be able to ask questions at the end. So if you have any questions, please ask at the end. So what's passive house about? Why is it so special? Well, the principles of passive house are energy efficiency and how that's achieved. You're trying to get the passive solar gain from the sun, orientation, insulation, windows, air tightness, all of the things that make a sustainable building, and we'll come on to those individually in a minute or two. And why is passive house and energy efficiency sustainable? It's very, very simple. You can talk about materials, which is important, which we'll talk about in the Crest building, the choice of materials and life cycle costs and all the rest of the materials and where the materials come from, and if it's sustainable. But the thing about energy efficiency on its own and passive house, which is an energy efficient performance, is that it reduces CO2. You reduce CO2, you stop burning fossil fuels, you save the environment, save the earth, all of that. It's all about reduction of CO2. So I see that as a massive side of passive house sustainability. We are interested in materials, but we look at energy efficiency as the primary sort of place where we can make a difference. And being an architect and being a designer, if you think about it, the one opportunity you do have to be sustainable is in designing the fabric of the building. You have an opportunity to choose the insulations, the type of material, how it all goes together, the services, how the whole thing goes together to make a building which is truly efficient and sort of truly revolutionary in terms of sustainability. So, I suppose the other side to it, which is good news for anyone building a new house, is that if you build to passive house standards, your space heating requirements are extremely low. This graph showed typical housing stock on the left-hand side, which is highly inefficient. If you look at the red, that's the amount of space heating required. It goes to reasonably thermally efficient, low energy house, right down to passive house on the right-hand side. And you can see that a passive house requires virtually no heating. You can go probably 6-8 months of the year without any heating at all. It's just a little top up in the winter time. Very, very small, and that will be your house heated. And I know from experience this does work from houses that we have built. So very, very efficient in terms of space heating, and that translates into money as well. If you build a passive house, extremely cheap to heat. In fact, a good way of looking at it is saying what's the cost of heating the hot water is a similar sort of cost to the cost of heating the home. So you're looking at 300 or 400 euros per year maximum. So how does it work and what makes it special? Well, basically it's building physics. It's putting all the right things together in the right way. There are 5 different elements. You have your walls, your fabric, insulation, your windows, the heat recovery with ventilation, air tightness, and thermal bridging, which we'll come on to in a little minute. Air tightness, this is probably the most difficult aspect of building sustainably for builders. Air tightness in passive house, extremely low level. It's typically 10 or 15 times lower than the current building regulations. And our experience has been this is the most difficult thing for builders to get their head around in terms of construction. A builder has to take a totally different view towards it. They have to, the building first of all has to be detailed differently so it's capable of being made airtight, and all of the junctions have to be taped adequately, otherwise the building won't function and you won't have Passive House certification. So airtightness is key. And I suppose you think about airtight, you think, oh, do I want to be in a building that's extremely airtight? But Passive House gets around that with a ventilation system. Windows, high quality windows and doors. The slide here shows a typical Passive House window. The thermal image there shows a Passive House window on the left and a typical single or double glazed window, which is the red, leaking all the heat. So extremely highly efficient windows. The good news is, company in Cork, Munster Joinery, are now making Passive House certified windows. They're being exported all over Europe and in fact to North America, and they're extremely competitive in the market. So they're being made locally. So this idea that people would have about Passive House being expensive or outside their reach is no longer the case. The industry has caught up in the technology and it's not as expensive as it used to be. So you've got this building that's extremely airtight. The problem is it's going to get a little bit stuffy with the windows closed in the winter time. You must introduce ventilation, so there's a certain amount of background ventilation which is introduced to all these buildings. Every room is either hot, warm, fresh air going into it, or the stale air being extracted. So 24 hours a day there's air moving around the house. But the key thing about the ventilation is that we're recovering the heat that's extracted. So in your typical house at the moment, you turn your fan on in your bathroom, it sucks that hot air outside. In this case, the hot air is recycled through a ventilation system. Insulation, high levels of insulation. I'm not going to be prescriptive about how that's done. If you use timber, it's more sustainable than using blockwork or using other forms of insulation. But we are actually building, some people in Ireland want a block house because I think it's more robust and more long lasting. So we're doing both blockwork and timber frame passive buildings at the moment. So lots of insulation in the walls. Thermal bridging, just an example of the detailing, and this goes back to the architect's details, an opportunity for the architect to detail out areas where the cold from the outside can get in contact with the warmth from the inside. The red line is the heat being lost through the ground floor slab out onto the slab. And that's our little Passive House just outside Bangor. That's the plan. You actually plan it so that the main living spaces are south facing, so they're getting the maximum benefit from the sun. So it's planned like that. It's a very simple shape as well, a simple form. It doesn't have lots of projections, which makes it more efficient. So that's good as well. If you look at the elevations, you can see there's more windows on the south side to the north side. The house itself is a sort of modern aesthetic. You can see there's a picture of the living room fireplace, and I said these houses are very efficient. A little bit of data on this house. The people have been living in this for a couple of years. They actually work in Dublin, the people who own this house. They don't stay in the house during the week, and last winter the house never went below 15 degrees throughout the winter with no heating on. So whatever way it's working with the sun, passive heat things, the house doesn't cool down below 15 even when it's 0 outside. They come home at the weekends on a Friday night, and you can see the little fireplace there in the living room. That's about a 5 kilowatt wood burning stove. They light that for an hour or two, and I quote, that keeps the house warm for a day or two. So that's how easy it is to heat. They have no other heating system. They do have some electrical fixed radiators if they can't light the stove, which they've never used. And I think they have 6 kilowatts in total for the house. But that little stove is keeping them warm at the weekends when they're there. So as I say, an hour or half an hour a day heats the house for a day or two. So that's how easy it is to heat. So that's our Passive House, using all the principles we talked about before. That was constructed about 3 years ago. We were fortunate enough to win a competition to build a sustainability centre in Enniskillen. This was an EEC funded project, and it was meant to be a sort of flagship for sustainability itself. The client were an educational college, and they were very keen that this demonstrated the ethos of the college. So this is a passive house building. It's also BREEAM Excellent, which is a UK sort of criteria of sustainability, which includes water use, embodied energy, transport, all of those other things around sustainability that isn't just about energy efficiency. So it's energy efficiency first and all these other things as well. So it's BREEAM Excellent because of energy efficiency. And when we went to the client, they said to us, well, Paul, is there anything else we can do to make this building special? And I said, well, yes, there's something you can do very, very easily. I said, you've got a building that's very energy efficient. It's only going to take a very small amount of PV electric to make it carbon neutral. So they took a decision to actually make it carbon neutral as well. In order to do that, like carbon neutral in the definition is enough electricity to heat the building, to do the lights. So it's heating and lighting provided on site with renewable sources. What they actually provided was 12 kilowatts of PV panels, and that was enough to make the building entirely carbon neutral. So actually now they've got no running costs for the building. The concept of the building, the dark part is the existing college, the grey is the building. It was designed to face south for maximum glazing for passive solar gain under passive house, and also for the PV panels which are mounted on the building. It's basically an educational building, demonstration and lecture areas, and the design, I hope, is a reflection of the sustainability criteria. You can see that the elevations, the one with all the glazing is south facing, the other elevations are north facing. A big element of the building is the overhangs. There's a lot of glazing, but also a risk you run with passive house. Because they're so efficient, you get a massive, well, a problem with overheating in the summertime. If you have overhangs around the building, that designs out the problem with overheating. So that's why it's taken a particular form. And that's really a sort of putting together the three things that make this building different, because it is these three sustainability criteria together. Construction then, BREEAM Excellent meant that we were going to use materials that were sustainable from sustainable sources. So rather than using a steel frame, which is very high in embodied energy, we thought we'll do this in timber, we'll use a renewable source for this. We used glulam beams, so it's an entire wooden structure from glulam beams. And the walls are made from SIP panels, which are basically plywood sheets, timber in between, and insulation factory applied between them. So the walls and roof are SIP panels made from timber and insulation as well. A couple of shots of the inside. The form of the building is designed so that there's light coming from the south down into the spaces as well, so that again the maximum amount of energy is taken from the sun in the winter time whenever the building is cold and will need that sort of passive solar gain. And there is a little bit of underfloor heating. You can see in the slide there on the left hand side, there's a little bit of underfloor heating in the corridor, and there's a little bit like that in each of the rooms, just for that time in the winter time whenever it needs a boost of heat. I can tell you it is heated with an air source heat pump. It's a 4 kilowatt air source heat pump. Your electric kettle at home is 3 kilowatts, so it's just slightly more powerful than your electric kettle, and it provides enough heat for the building in the winter time. So it's 500 square meters, 5,000 square feet. So that gives you an idea again of how efficient it is to heat. And the heat pump, of course, is powered by the solar panels. Just a little image of the building towards the south east side. Again, the large roof overhangs, the glazing high level going down into the spaces, and the corridor there, and just an indication of how it's looking at the moment on site. The interior of the building, we as the architecture of the building, we expressed the glulam beams as a sort of sustainable and visible part of the sustainability of the structure. We used as many renewable and sustainable materials. As you can see, timber throughout, LED lighting, and it has created a very comfortable, warm and pleasant building. And I suppose the other technology is whenever it does get hot in the summertime, the windows will open automatically to vent the building, because it does warm up in sunshine, obviously, so it vents itself automatically. That's just a picture of the lecture room space at night time. You can see the glulam beams, see the windows, the higher ones will open, as I say, whenever it gets very warm. And that's it at night time from the front. And the grass hasn't grown on that slide yet, so we're waiting for the grass to grow, but that's the final slide of the building. So that's me. I'm probably finished early. Thank you very much. So, thank you.
Thank you very much, Paul. Does anyone have any questions for Paul? And if you can speak really loudly, because the background noise is incredible.
Thanks very much, Paul. Excellent presentation. Just you mentioned this passive solar panel storage, or an element of solar panel storage from the sessions. How is that stored?
It's not solar thermal, it's solar PV. We actually fixed a series of PV panels onto the side of the building and just, used those.
Just wondering, did you consider using very change materials, glass board, or something like that to actually capture that heat when it does come into the building?
No, we didn't, but I know that's a way of thermal storage. Yes, no, we didn't do that. But yeah, I think that technology is coming down the road. Yeah, where it changes the state. Yes, thank you.
Any other questions? Could I ask you one, Paul? Just if a passive house has to have, I think it was 15 kilowatt hours per square meter per year, what actual energy consumption were you achieving on these? I may have missed that, I don't know.
Yeah, you're quite right. Passive house, there's a threshold. I think it's a good thing about passive house is because it's prescriptive and you must hit certain targets. So it's not a sort of wishy-washy, you must do a certain thing, it must perform to a certain thing. The passive house in just outside Bangor there, we talked about their energy bill for space heating where they simply light the fire. The hot water is heated with an air source heat pump. Their electric energy bill for a quarter, 3 months during the winter was about 420 euros, something like that. So I mean, they still use energy. They have to heat the water during the winter time. They have solar panels on the roof, thermal solar for the hot water, but during the winter time you have to heat the water. So that's their energy bill during the winter. In the summer it's about half of that because they're really only using lighting and using energy for appliances.
Thank you very much, Paul. That was brilliant. Thank you.